imaging, navigation, and robotics is all combined and managed through a single user interface, like the image of the brain, which is the computer, and then you have the eye, which is our imaging device, the 3D mobile C-arm, and then you have the hand, which is now the robotic robot coming into action.
What if spine surgeons and perhaps, dare I even say, interventional radiologists had a simple, integrated way to capture and generate 3D images in the OR or procedure room, to navigate to key anatomical landmarks, use a robotic arm to ensure proper hardware positioning? Well, that's the challenge before us tonight. And our first pitch is from Laurent Chabanat from eCential Robotics. So let's watch. Merci, Laurence. Thank you very much.
Well, Laurence, that's an elegant video, and I enjoyed watching it. And what I note from it is it's a powerful-looking robotic arm. And in the video right now, you have it set up to do, the classic navigation, drill guide-based navigation. What do you see? What other things do you see next for that robotic arm? It's certainly capable of more than holding the drill guide.
You see in the video, today we focus on spine, and we have started with a very simple procedure, which is targeting for a needle. But obviously, our platform is now built and expandable to many other types of application that could be either in spine, so adding some more intelligent tools at the end of the robotic arm, combining that with intraoperative planning that you can get from the imaging, and to move a step further. So this platform is really incremental and can be augmented by many different tools, applications for different procedures.
I wouldn't say it's a mature sector at all, but how will you distinguish or separate yourselves from the players that exist in the space currently?
Yes. So our very essence at eCential is to focus on the essential of the workflow, and so the technology is completely fully embedded. So as you mentioned, on the market there are some integration of imaging with robotics, but usually there are different devices from different companies, so they need to communicate, find a way to manage two devices. And our platform is really unified by design. So that means that it's a single user interface to manage all the functionalities of the systems.
Thank you very much.
Audrey, and then we'll finish this round with Tony.
All right, thanks, Scott. Well, first of all, I have to congratulate you. It's a beautiful machine. So it's not just integrated and unified, but it really is pleasing to the eye. In terms of clinical benefits for the surgical team and for the patient, what can be demonstrated with your technology compared to others that are already on the market?
Okay, so for at the moment we start to show clinical results that show equivalent to what is on the market. One serious benefit we believe is that we have a real low dose device, and we have a recent publication that shows that we are 5 to 6 times less radiating than existing system in the market. So that's one benefit for the patient, but also for the staff, because all this 3D imaging, all the staff can go out of the OR and they don't get any radiation during this stage of the procedure. Also, in terms of accuracy, we believe that having this unification, it reduces the different steps that are commonly needed. For example, you know that we need to register the imaging with the patient. This is done automatically, simultaneously, instantaneously with our device because of this very strong connection between imaging and navigation.
Thank you for that. And 5 to 6 times less radiation is not a small feat. So that will be terrific for all involved. When the registration is happening and the OR team has left the room, how long are they out of the room? Let's say, how long does that take?
It's about 30 seconds. To do the spin. And then it's 30 seconds more to do the 3D reconstruction and have access to the image of the patient. So it's quite a short time.
And that seems quite a bit less than registration with current systems. Very good. Thank you so much.
You're welcome. Thank you, Audrey.
Thank you, Audrey. That's terrific. I'm going to come back to this question of radiation exposure, because I see you get 90 shots to get the image. Mm-hmm. Now, when you say 5 to 6 times less, is that in total? We
play on different parameters to reduce the exposure. So first, as you said, we need only 90 2D shots to recreate the 3D image, where commercialized system usually they need at least 380. So that reduces first this amount. And then we also have a specific trajectory. The mobile C-arm is an actual robotic imaging system. So it can move on 5 different axes, and the trajectory is not circumferential, it's kind of an elliptical, and it enables us also to play on the distance between the X-ray source and the actual anatomy of the patient, and we can increase this distance as much as possible during the acquisition of the X-ray, and that also participates in reducing the total X-ray exposure to the patient.
Related to your FDA pathway and whether you intend to do this sort of piece by piece or as a system, and whether or not you have had sufficient meetings with them to know if you're going to be required to submit clinical evidence with your submission.
At the moment, we have received FDA approval for the imaging part of our system, and we are currently building the file for submitting navigation and robotics part of our system. So the submission is expected sometime by the end of the year.
Fantastic. That's good clarity. Thank you. Please take it away, Tony.
Congratulations on the good success that you have achieved and the company and team have achieved together thus far. Now, let's talk about success tomorrow. And Viscogliosi Brothers, as an investor in the neuromusculoskeletal space, one of the most important criterion that we look at is people. We seek all-in entrepreneurs. Now, your president, he has great experience, Monsieur Levalet, with the previous success in robotic technology, orthotaxy. Tell us about your people and the team and why this team is so good.
Very, very interesting to talk about people because, of course, the people, they are the basis and the core of the spirit and all that comes from it. So yes, so Dr. Lavallee, our president and founder of eCential Robotics, is really a pioneer in the robotics space. So he has a long history of entrepreneurship. He has built several companies. They were all successful, we would say, with some exits with many other actors in the market. So he's really a key person for eCential Robotics.
So in this case, the average physician is just average, not a superstar. So how does this technology make the average physician, the average surgeon, so much better?
Well, good question. Well, we believe that the platform, the applications that we are developing, the one main criteria is really to focus on the workflow and make sure that the surgeon can really concentrate on the essential tasks. And the technology that we bring on top of that is not, I would not say transparent, but it does not bring any load to the OR. And we think that we have we are getting there where we will be able to use our system for really routine cases.
Thank you so very much.
Okay, well, thank you, Laurence, and audience. Now it's time to see what you think. So from what you've heard, and we'll put up the poll, is this a winner and a game changer, or does the company need to go back to the drawing board? An overwhelming group who think that this could really challenge the standard of care. About a quarter of the people think it's promising, right? And maybe a little bit more work required, but I think this is really very encouraging and great answers to the questions. If anyone would like to contact eCential Robotics directly, here's the information